Okay, this we're going to look at fluid flow, and this is going to be the last concept we're going to talk about in this chapter, the chapter on fluid mechanics. So I just want you guys to pay a little bit of attention because we're going to wrap up with fluid mechanics in this slide, in this video. If you look at the example we have here, we're going to look at three different regions at which a fluid is flowing. We have region 1, region 2, and region 3. And you can see the streamlines that indicates the flow of the liquid. You see the flow of the liquid in region 1, in region 2, and region 3. Now, what one of the things that we have to see or we have to understand is that the streamline moving from east to west or from left to right is always parallel to the fluid velocity at any point in time in this flow. So the streamline that you see in red is always parallel to the speed or the velocity of the fluid flowing. And now when we consider this case, there are a lot of things that we can depict or we can get from this diagram. The first thing that we have to understand is that the fluid speeds up when it goes from a wide path to a narrow path. So if a fluid is moving from region 1 to region 2, you see region 1 is wider than region 2, and therefore when the fluid gets to region 2, it speeds up because it's moving from a wider region to a less wide region. Notice also the change in the spacing between the two adjacent streamlines. You see that if the spacing between two adjacent streamlines in region 1 compared to that of region 2, you see the spacing in region 1 is greater than the spacing in region 2. That depicts the speed because the speed has increased in region 2. So what we are saying is that the fluid runs the fastest in the region where the spacing between the adjacent streamline is the smallest, and slower in the regions where they are spaced apart. So if we want to be able to grade the fluid velocity for these three cases, for region 1, region 2, and region 3, we're going to say the velocity in region 2 is the greatest, followed by the velocity of region 1, then the velocity of region 3. And we said the reason why we have that is because if you find the distance or the difference between two adjacent streamlines in each of the regions, for region 1, you see the distance between two adjacent streamlines is very small, and the distance between two adjacent streamlines in region 1 is small, and that for region 3 is far apart as compared to the other. Now, the second thing that we can be able to get from this diagram is that one can also compare the pressure between the regions of high and that of a low speed. Now, what we're seeing is that now because the speed in region 1 is lower than the speed in region 2, the pressure in region 1 will be greater than the pressure in region 2. So it's like an opposite relationship. It's an indirect relationship. So because the speed here is greater in region 1 is greater, sorry, because the speed in region 1 is lower than the speed in region 2, the pressure in region 1 will be higher than the pressure in region 2. So as a matter of that, where streamlines of a fluid are close together, flow speed is greater and the pressure within the fluid is less. And that principle is what we generally in physics refer to as the Bernoulli principle, and we can state that. Now, what is the statement? So if we consider the statement, where the speed of a fluid increases, internal pressure in the fluid decreases. Now you can see in the diagram below, you see the pressure P1 and the pressure P2. Now P1, if you look at it, you see that P1 is higher than P2. You can actually see that difference, right? You can actually see that difference because at the region P1, the fluid is moving slowly as compared to where at region P2. And because the speed of the liquid in region P1 is very, very slow, the pressure P1 is higher than P2. So we can see the definition or the statement of Bernoulli principle, where the speed of a fluid increases, the internal pressure in the fluid um, decreases. So the Bernoulli principle, just to go back, it was discovered by Daniel Bernoulli in the 15th century. He was a Swiss scientist, and states that where the speed of a fluid increases, the internal pressure in the fluid decreases. That's just something we've been talking about. So let us look at various applications when it comes to Bernoulli principle. Now look at the picture that we have on the right hand side. Now if I hold a paper and I blow on the surface, on the top surface of the paper, what I'm actually doing is that I'm increasing the velocity or the speed of the air moving on top, and as such decreasing what? This pressure. So what is going to happen is that the pressure on top of that paper will be lower than the pressure at the bottom, and therefore what happens, the paper is going to float. And now this same principle happens when we are looking at airplanes. Now what happens is, the way the change in the pressure in the fluid flow is essential physics that explains how airplanes fly. Like I've explained, the wind is shaped in such a way that the air that air tries to flow faster over the top of the wind than over the bottom. Now what happens is that now, because air flows faster, if you look at the diagram on the left, on the right, sorry, because the air flows faster um, at the top, the pressure at the top is very, very small. And that means that the pressure at the bottom, or the upward pressure, will be very, very high. And that's what sustains the plane in the air. And that's an application of Bernoulli principle. So we can also look at the Bernoulli boats. And so we have two boats in the sea, and I'll just read and try to, so that you guys can understand. The Bernoulli principle explains why passing ships run the risk of sideways collision. Now, those are two ships. If you look at the diagrams we have, those are two boats. Now, water flowing between the ships travel faster than water flowing outside. So, at the in between those two ships, the water that flows there is faster. Now, because the speed of the water that flows between those two boats is faster, it means the pressure in between those two ships is very small. Now, that will mean that the outside pressure acting outwards on the boat is very high, and because of that, the outward pressure will push those two boats to collide together. Now, in order to reduce the risk of those two boats colliding, then it has to be steered in different directions. So one has to be steered towards the northwest, and maybe another one steered towards the northeast, just to ensure that there is no collision between those two boats. And that's a principle that we use all the time. And we can see that so far we've talked about a lot of things that has to do with fluid mechanics. We've talked of pressure in gases, in liquids. We've looked at Archimedes principle. We've looked at Bernoulli's principle. We've looked at the various applications that we have. And so this is like the end of this particular chapter. I really hope that you guys understand, at least to a certain degree, what we've been talking about for all these videos. And if you have any questions, like I said, you can just go to log into uconnect, go under communications, and under there you have a chat. On the chat you have where we can talk, so you can always message any questions you have regarding the videos, and all the videos for the next chapters will be coming in the days ahead. So thank you, and you have a wonderful